All right, so we're going to talk about non-ideal column behavior. Continued here, so we're going to talk about eccentricity. So eccentricity is when we have a small deviation in where the force is applied and where the column itself bends. So we can say that distance, we can call it the eccentricity, or it's relatable with this lowercase e. All right. So, so we can say that the moment along the column for our applied load P can be equal to that applied load P times the eccentricity plus the applied load P times the displacement of the column along the length. Right? We also know that that mz of x function is equal to the Young's modulus times the moment of inertia times the second derivative of that displacement function along x. Right? So if we have that case, we can set those two equal to each other, and we can rearrange, and we have another differential equation, and another ODE, second order linear ODE, and if we solve this equation, a solution to that equation is this solution here, where K is just equal to the force applied along the column divided by the Young's modulus divided by the moment of inertia. So we can again use the boundary conditions to help solve for our two unknown constants, C1 and C2. And if we do that, we get C2 is equal to epsilon E, and we get C1 is going to be equal to the tangent of KL over 2. All right. So so if we do that, let's see here. What are we going to get? So if we do that, so what we end up getting is you get VC of x is equal to this function here, and then we know that the maximum displacement will occur at x is equal to L over 2, so that's where also the moment will be the highest. All right, and so if you plug in all those values, all right, from this solution here, up here, I should say, here, what we'll end up getting is we'll get this equation here, which ends up being, we have a sine squared plus a cosine squared term. We know that's equal to 1, and that 1 is over a cosine term, which is equal to secant. Right? So that's how we end up getting our maximum moment equation equal to the force times the eccentricity times that secant length.